Okay, here we have another random variable question where again the variable is defined in a combinatorial way. We have a fair coin, which is tossed 4 times and the number of tails is denoted by capital X, to find its probability distribution and then its expected value and variance. Please do pause the video and have a go. To find the probability distribution, that's the little table we had before where you have the possible values of the random variable, which I'll denote with little x, and then the probability that capital X equals that particular value underneath it. So you could get no tails, 0 or 1, or you could get 2, or you could get 3, or I suppose you could get 4. Now, to fill in these probabilities, we could draw a big old tree diagram. In fact, we'll just very quickly see what that would look like. Sort of first one, second one, second outcome. But as you can see, it rapidly gets quite big and complicated looking. So we'd actually much rather not draw a full tree diagram. So let's have a quick think. How many ways could I get 0 tails? Well, that would be if the coin came up heads 4 times in a row. There's a half chance of that happening on each occasion, and they are independent, so whether a head comes up doesn't affect the probability of the next coin toss. So we can actually fill in the first cell just by doing a half times a half times a half. I'll actually write that as 1/16 there. Now, how many ways could I get 1 tail? Well, let's just have a quick look at that. We essentially need to count the number of ways it can happen, or the number of paths through the tree. So we can make, it's not too hard to make a list. You could have tails, and then heads 3 times in a row, or you could have then tails. So there'll be 4 of these. But there is another slightly more sort of combinatorial way of thinking about this. There are 4 slots here, 4 coin tosses, and you must choose one of them to put the tail in. So the number of ways of doing this is just 4 choose 1, so which is 4. And each of them, so the probability we're after, that x is 1, is 4 times, and then each of these specific outcomes has probability 1/16, half chance to the 4th. So you get 4/16. I'll write it as 4/16. I won't simplify that down actually, I'll just leave it unsimplified for the moment to emphasize that the 4 is the number of ways it can happen. Okay, so let's continue on that theme. How many ways could you get exactly 2 tails? Well, we could list all the ways it can happen. I'm actually writing them here in sort of, I guess, reverse alphabetical order to make sure I don't miss any. So here they are. And if you do this, you'll discover that there are 6 of them. But again, we'd rather have a more combinatorial way of thinking about it. So 6 is actually 4 choose 2. Which of these 2 slots, of these 4 slots, are you going to put the tail in? So the probability that x equals 2 is, I'll now write it as 4 choose 2 times a half to the power of 4. Yes, that's 6/16, so let's put that in the table, 6/16. Now, because the coin is fair, the chance of getting 3 tails is exactly the same as the chance of getting 3 heads or 1 tail. So this little table will actually be symmetrical, 4/16 and 1/16 there. So that's called the probability distribution of x. Okay, we'll come up with another distribution in a second. Second part asks us to find the expected value of the variance. We're now familiar with that. E of x is sigma xi pi, which is 0 times 1/16 plus 1 times, I will now simplify it down to, no, perhaps not, perhaps I'll leave everything over 16. Probability is probably the only area where sometimes simplifying isn't worth it, because we're going to have a common denominator if we leave everything over 16. 2 times 6/16 plus 3 times 4/16 plus 4 times 1/16, which comes out to 0 plus 4 plus 12 plus 12 plus 4/16. And that actually simplifies out to be 1. Now, I don't know, I hope that that's in some sense not surprising. If you have a 50%, I beg your pardon, not 1, 2, it comes out to be 2. If you toss a coin 4 times, you'd expect to get tails roughly half the time, or roughly twice. Okay, so that hopefully isn't that surprising. Variance of x, again a familiar formula now, sigma xi squared pi minus e of x squared, or minus mu squared possibly. So that is 0 times a 16th plus 1 squared, or 1 times 4/16 plus 4, or 2 squared, times 6/16 plus 9 is the 3 squared times 4/16 plus 16 times 1/16 minus 2 squared. 2 is that expected value. Again, try not to forget to subtract that. So again, all over 16 we have 0 plus 4 plus 24 plus 36 plus 16, all over 16 minus 4. Let's have a look what that simplifies to. If I add the 4 to the 36, I get 40, 64, 80. 80 over 16 is actually 5, so all of that simplifies out to just be 1. So in this particular case, this random variable has variance 1, which means it actually also has standard deviation 1. So the mean is 2, and the variance is 1.